All right. Hello, everyone. Welcome to our first workshop in our Data Lab series for fall 2024. Thank you so much for joining on Zoom. Those of you on Zoom, please do feel free to stop me, unmute yourselves, put questions in the chat if you have any questions on anything I'm about to cover, or if you need anything repeated or clarified, please do let me know. I'll start with an introduction of myself. My name is Molly Webb. I'm a GIS developer here on the data services team at the university libraries. I've been here with the university for about 9 years, doing various GIS related tasks. But today specifically, we're not going to be talking about GIS or spatial data. We're going to be talking about cleaning data with Python. So hopefully this will just give you some ideas on things that you can do to make your data a little bit more manageable with hopefully a small amount of effort. Before I go ahead and get started, I did send out let me see here. I did send out a link to the Google Drive folder where all of the materials are for the workshop today. I'll go ahead and I'll just drop that link in the chat so you have that handy. Oh, nope. There we go. There's the link to the Google folder. And while I do some introductory remarks here about Python, go ahead and navigate to this folder. And I'd like you to take this entire folder, workshop data, right click and go ahead and click download. This is the data that we're going to be working with today in the workshop. So if you plan on following along with me, go ahead and just get that download started. It'll just save us a few seconds when we get to that portion of the workshop. So again, go ahead and just mute or unmute or put your questions in the chat if you have any questions. Okay. So just to get started, I want to talk about a few different things, okay? First of all, when would you want to use Python? And specifically, when would you want to use Python when there are many other options out there for data cleaning? Like we can use Microsoft Excel, we can use text editors. There's open source products like OpenRefine, R&R Studio. There's licensed products like Tableau Prep, which is a GUI data cleaning platform. And then there's kind of the built-in data cleaning functionality that comes with some of the other statistical applications like Stata and SAS and SPSS. Well, so the reason why I like to use Python is because it's a fairly easy scripting language to pick up. There's lots of different resources out there for getting started with Python. There's lots of different additional libraries that will help you extend the functionality of Python. And just due to that universality, that is why Python tends to be my go-to when I'm doing data cleaning. Another great reason about using code-based cleaners in general is that the steps that you take when you're cleaning up your data are recorded kind of by default in the code. This is something that is really important for us as researchers to make sure that our work is reproducible and defensible. And so using a coding language like Python to do your cleaning can really help with that documentation, both for others and then the future you, when you say get a new data set and you know you want to run the same steps on that as you did previously, your code is all right there and you can tell exactly what steps you took to clean up your data. So I already mentioned, if you got an email from me early this morning, kind of first thing, maybe around 9 a.m. or so, there was a link to a Google Drive folder where all of our materials for the workshop are. And we're going to be running the code in a Google Colab notebook, which is basically like a web-based Python notebook that makes it really easy for us to write and run code. I'm going to go out of my slideshow just for a moment to show you. Here are the contents of that workshop, and I'm going to go ahead and drop that link just in the chat one more time for anybody who just joined us. Let me just grab that. Okay. And so in our Google Drive folder here, we've got the PowerPoint slides that I'm going through. So you'll have those to reference later if you'd like. We've got this .ipymb file, which is our Python notebook. I'm going to go ahead and go into that. And then the next thing we have here is our workshop data folder. All right, so I'd like you to go ahead and you can right click and download that entire folder. And then within that folder, you're going to see a series of different CSV files that we're going to use today. And so we'll take a little bit of a closer look at what's in these CSV files when we get started with the code. But basically, we've got our data, we've got our presentation, and then we have the actual notebook. I'm going to go over to the notebook right now just to give you a little tour. If you haven't used Google Colab or Python notebooks in general, they are a very handy way to basically interactively run different Python snippets. And it's great for instructional purposes because we cannot only have our little Python code snippets here, Python code blocks, but we also have the ability to add text. And so we can basically make this kind of a step-by-step walkthrough of what we're going to do throughout the workshop, what each code snippet does and things like that. So I really like to use Python notebooks for teaching. And when I'm writing my own Python code, sometimes I'll use a Python notebook because we can print stuff out and visualize things pretty easily. And so if you are just getting started with Python, maybe check out Google Colab because it's a really great platform to really easily be up and running with Python. Okay. Over here on the left-hand side of the screen, we've got the table of contents. And so we could really easily skip around in the content if we want to, using the table of contents on the left-hand side. Underneath, so that's that top icon is going to show us that table of contents. The next icon is going to be our find. So if we need to find certain code snippets or maybe do a find and replace, we can do that here. Once we start to create variables within our Python instance, any variables that we create will show up here in our variables list. And so that can be really handy to keep track of what is the variable and what type it is, how big is it. And so this can be a handy window just for kind of easy access to our different variables. Secrets involve in authentication, so we're not really going to be doing anything like that today, but if you have some protected resources, you can save them here. And then finally, we've got our little files area, and this is actually where we're going to upload files to be able to have our notebook see them and read them. And then whenever we output files from our notebook, they're going to appear in this window as well, in this little files section. All right, so that's these icons over here on the left. The other things I wanted to show you is just the code snippets. And so if you have something that you're trying to do, you could describe that in the code snippets and then various, we could say like save CSV. And this gives us some hints on how we might be able to save our files off. And then finally here, the command palette. This gives us just an easy way to run different things that deal with our notebook. So for example, as we run our cells, we're going to be getting different outputs. And so if I wanted to just clear all the outputs, I could say clear all outputs, and then that would run it for the whole notebook. So that's just a little tour of what's happening here on the left side of our window. I'm going to click over here on this More Actions button and say close this tab. And then I'm going to click this X here to collapse that leftmost panel. So we have our full screen real estate for our Python notebook. Over Zoom, my Zoom attendees here, if you are having any trouble getting to these materials, please do let me know and we'll get that worked out. If I don't hear from you, I'm going to assume that everybody's okay. So just feel free. We're a small group today, so feel free to interrupt me and we can make sure that everybody is on the right track if you do choose to follow along with me. Okay, any questions? We good for now? Okay, thanks. All right. So the first thing we're going to do is we're going to load our data files into our notebook, okay? So we're going to be looking at two different ways to read files here in our notebook. We're going to be taking some files that are saved locally on my machine. We're going to be uploading those to the notebook so that the computing environment here has access to them. And then we'll also be doing an example of accessing a public file that's saved on Google Drive. So a couple of different ways we can get to our files. If I go back to my Windows Explorer here, if I look in downloads, that is where the workshop data folder downloaded when I downloaded this from Google Drive. It's going to download as a zip file. So I'm going to right click and I'm going to say extract all and extract. And that's going to basically create or unzip this folder, and it's going to create a new folder with that same name. If I click into it, we've got our workshop data, and then within here is our CSV files. So the CSV file we're going to be using the most today is this sample survey data file. So I'm just going to pop this open really quick just to show you what's in it. It's just a simple CSV, just a few columns where we have a unique identifier or case number for each of these observations, city, state, zip code, and an income value. So super simple. We're going to be doing some work with that. I'm going to close that. Don't save. And then we've got an additional CSV here, STL city population 65 plus. So what this has is just some different zip codes here in the St. Louis area, and then some population values associated with each zip code. Okay. Don't save there. And then finally, I'm just going to open up one of these NAICS files. These are all formatted the exact same. We just have 5 different files. And what this is an export of each record is essentially a grocery store location around the US. And so there's quite a few columns of information in this particular file. Hopefully we'll get to be using this towards the end of the workshop today. And each one of the 5 files that have this similar naming convention are all formatted the same. So this will be how we practice bringing in multiple files into our Python notebook. Okay. All right, so now that we know kind of what's in these files, let's bring them into our Google Notebook. So I'm going to go back to the left-hand side of my screen and I'm going to expand the Files option here. And then up at the top, there's some icons here right above the files list. And I'm looking for the leftmost one, Upload to Session Storage. So I'm going to click this Upload to Session Storage button. Then I'm going to navigate to my downloads or wherever you saved your files from the Google Drive folder, navigate to that location. So I'm going to navigate to where those are. I'm going to click and drag a little polygon to um, highlight all of these or select all of these. I could also hit Control A. That would select all of these records. And then I'm going to click Open. It's going to give me a little warning that once we close this notebook, all of those files are essentially going to be deleted from the memory of the notebook. And so this is just giving you a warning to say, make sure that you save your files elsewhere, because once you close this network or this notebook, they're not going to be there anymore. Okay, so I'm going to hit OK on that. So it takes a couple seconds, but now I can see that all of those files are saved here in my files menu. So now if I tell Python, oh, open this file, it will know what file I'm talking about. So that being said, I'm going to close this and just double check any questions on downloading the files or bringing them into the notebook. Yeah, absolutely. So if you're here with me in the notebook file, over on the left-hand side, there's a little file folder icon there. And once we expand that, then we're going to go up to this top section with these 4 icons, and we're going to choose the leftmost icon, Upload to Session Storage. Do you have that icon there? Okay, awesome. So when you click on that, is it opening up kind of a file explorer for you? Okay, so from here then you need to locate where you saved your files, and then you can just hit Control A to highlight them all and then click open. That will bring them up into your Python instance. File, it's email, zip file. Ah, yes. Okay, so let's take a step back then. I'm going to go back to my File Explorer, or my Windows Explorer basically. And so when we downloaded the files, they did come as a zip folder. So what we need to do is right-click in that zip folder and go to Extract All, and then hit Extract. And then that's going to expand the zip folder, so you'll see all those files there. And then try again, going back to that file icon and going to upload to session storage, and then see if you're able to get those files up there. And I'm not seeing anything in the chat from Zoom, so I assume everybody's okay if you are indeed following along with me. You good for now? Okay, awesome. Thank you so much for asking me to clarify that for you. Like I said, we're a small group. I want to make sure everybody is following along if they choose to. Okay, great. So we've loaded our data files into the notebook. Okay, awesome. All right, so now that we have our data files loaded into the network, I'm going to go back to the presentation because we do have a couple more things about Python that I want to make sure that we address. Okay, so first of all, Python on your actual computer. So if you have experience with Python, you might know this already, but I just want to make sure that we cover some of the basics. When we are talking about Python, Python has a few different ways of accomplishing tasks. All right. So when you first download Python to your machine, it's going to come with a series of built-in classes, built-in modules, and built-in functions. Okay. Now, classes are the things within Python that that basically hold information, if you will, and they hold different kinds of information. So each class, such as string, which is just text, integers, which are whole numbers, lists are going to be just like they sound like, lists of values, and so on and so forth. Each of those built-in classes is going to have a number of properties or characteristics about the class, and then they're going to have methods associated with them, which are built-in functions for the class. All right, so what is a function? Let's go ahead and go over to this third box here on the right, which is functions are things that actually do work or perform some kind of operation. So, for example, the first function here, length or len, this returns the length of the string or the integer or the list or whatever it is that we pass into the parentheses. So Python has quite a lot of these built-in functions. So right away, you're able to do things like print out statements to your screen and things like that. Going back to the middle section here, Python also has a series of built-in modules. So modules are things that essentially extend the functionality of base Python. So when you install Python first, it's going to come with all these things. But then when we're using Python in our scripts, we do specifically need to import these modules if we're going to use them. So, for example, the OS and the sys modules are going to tell us information about our computer and our operating system. The datetime module is going to allow us to work with dates and times like you would suspect. The math module helps us do a little bit more sophisticated calculations and so on and so forth. So these are not complete lists of the classes, modules, and functions, but these are just examples of the things that come along with Python when you first download it. Okay, now taking all those built-in things and moving them off to the side, you can also install third-party libraries within Python as well. So you'll hear libraries referred to as libraries or packages or site packages. And so these are things that have been written by typically people in the Python community, and you install them separately after you've installed Python, and they come with their own set of classes, modules, and functions. One of the more popular Python libraries is a library called Pandas, and this is a great library for data cleaning. It's the one we're going to be focusing on today. There's also NumPy, which helps us work with numbers a little bit more efficiently than just base Python. And then there's also a package called ArcPy, which interfaces with the ArcGIS platform within the GIS world. So these are just a couple of examples of third-party libraries that you're going to be installing separately after you've installed Python on your machine. Okay, so imagine this is your computer here. You can actually have more than one version of Python installed on your machine. And each version of Python, I'm going to call those instances. Each instance of Python is going to have separate libraries associated with it. So say I have 3 instances of Python installed on my machine. I might have a Python 2 version, which is kind of the older version of Python. And maybe I have 2 different Python 3 versions. So Python 3 is the current version of Python that is released today. So each one of these instances of Python can have their own libraries associated with them. So when you're installing third-party libraries in Python, it's important that you know which Python instance you're actually installing that library into. All right. Now, how to install Python and these libraries. We're not necessarily going to cover that today, but there is a lot of information about how to install Python, just many resources. But if you do have any issues or any questions, just reach out to me and we can walk through it together. But this is just to show you that you can have multiple versions of Python installed on your machine, and each one of those versions is going to have its own libraries associated with it. Okay, a note on AI. Basically, in my opinion, use it, all right? But you still need to have an idea about what the code is doing. So I would say that, some people are like, oh, AI is going to make it so we don't have to write code anymore. And maybe we won't have to work as hard to write code, but we still need to make sure that we understand what the Python code or any code that we write for that matter, we still need to know kind of what it's doing. And so that's why I would say, basic knowledge of Python is still a very useful skill skill, and I don't think that's going away anytime soon. But yes, by all means, please do take advantage of chatbots and, Chat GPT to give, especially if you need to just get over a little hump, like you can't quite figure something out, go ahead and use AI because, a lot of times it's going to be built in there for you, like we'll see in the notebook here. And so, there's no harm in using it. I still use it all the time, even though, I'm writing my own Python code. All right. So AI can help you understand and get the syntax correct. So just a quick review of some Python syntax. So we talked about classes before and how classes have properties associated with them. So whenever you're needing to access the property of a particular class, you're going to say the name of that class. Oops, and then the name of the property. So for example, if we have a data frame object that's in the class data frames, we can get the number and rows, we can get the number of rows and columns in that data frame if we say name of the data frame dot shape. That's going to return a tuple that has the number of rows and the number of columns in that data frame. So that's how we can get properties. Each class has different methods associated with it. So if we want to access a method associated with the class, the syntax is the name of the class dot the name of the method. And then within parentheses, you will have 0 or more values that are parameters. So that's information that gets passed into the method for whatever it is the method happens to do. So for example, the string class has a method associated with it called replace. And what that replace method does is it looks in a string for a particular substring, and then it replaces that substring with whatever you tell it to replace with. So if we have a string, we could say string.replace, and then the first parameter is going to be the string that we're looking for to replace. And then the second parameter is going to be the string that we're going to replace that string with. Okay, so that's how the syntax of methods goes. And then finally, we have the syntax for functions. Now, functions are associated with the library, the Python library itself, not necessarily a class. And so the syntax looks like there is you're going to call the library dot the name of the function. And then again, within the open close parens is going to be 0 or more parameters. And that's information passed into the function. So, for example, in the pandas library, they have the read CSV function, and that basically reads in a CSV. So what you do is you say, okay, I'm going to call pandas dot, and then read CSV is the name of the function. And then we're going to pass in one parameter, which is the name of the file we're going to read in. So that's just a little review on the syntax of working with class properties, class methods, and library functions. All right, before we get started actually looking at our Python code, just a couple of tips here. First of all, when you set up your script, I recommend setting all of your workspaces and local variables at the top or the beginning of your script. And that's so you don't have to hunt for them in the script later on. So you know automatically as soon as you open up the script, or maybe if you've passed the script to one of your colleagues, they know that everything they have to maybe change for their own environment is right there at the top. And so all workspaces and local variables at the top. Depending on the size of the data set, what I like to do is I like to kind of add columns as I work. So even if they're kind of like interim columns, and then right when I'm ready to maybe export the data frame, I will just narrow it down to only the handful of columns that I actually need and then export that as a file. So that kind of makes it easier. You don't have to worry about doing so much like kind of in place, but just adding new columns that might be copies of columns and then making changes to those and then pare it down when you're ready to export. Data types are very important when you're doing data cleaning. And so just a little note to make sure you pay attention to those data types. Of course, I mean, like, are they strings, numbers, numbers with decimals or whole numbers? Are they dates and times or just dates? So you really have to kind of pay attention to when your data comes in, what data type does Python think it's looking at there? And then finally, we want to make sure that as good data managers, we're paying attention to where our input files are coming from. And when we output files, where are those going to? So we don't have to hunt for them later on when we're like, well, I exported that. I don't know exactly where it went, but I know it went somewhere. And so you have to kind of hunt around for it. Try to pay attention to where you're saving things, and that will save you some time later on. Okay, just a quick note on the pandas library. So like I mentioned before, there is this structure called data frames. So data frames within pandas are basically like in-memory tables. So we've got just a little sample data table here that is our data frame. And then each data frame is going to have series, and series are basically like our columns. And then each row here is a record. And then each record is going to have an index value. So this is something that Python Pandas kind of holds in memory. And so it starts with 0. So our first record is going to be index 0. And then second record will be index 1, and so on and so forth. So that's just, we're going to start right away with working with data frames. And so that's just an example of kind of what a data frame looks like when we're talking about that in Pandas. Okay. What questions do you have on our kind of intro Python things before we actually get started with the code itself? Oh, no. You don't need to download Python now. And the reason for that is because within the Google Colab environment here, Python is already installed. And so nobody needs to download Python on their own right now because we're going to be working right within this Google Colab notebook. And see how at the top here, it's our file is a .ipynb. So that stands for a Python notebook file. And so the Google Colab environment is essentially an environment that already has Python. And so it's going to use its Python to run this code for us. So you don't have to download anything, but I really am glad that you asked. What other questions do you have?
So like, for example, after we go through all this with this Google Doc today, after that, can I like kind of use it in my Python?
Yes, yes. So just to repeat, sorry, and I should have been repeating the question for those of you that are online. So the question is, after we finish with our Python notebook, can you use this in your own Python instance? Yes, you absolutely can. So what I would do is going back to the folder with this materials in it, I would download this. And then you can bring that onto your own machine and you can run that within your own Python environment. Yep. Or you could just work with it right here within the Google Colab too. I really like to use Google Colab for instruction sessions like this because what it does is it makes sure that everybody is using the same Python environment. And so it doesn't matter if you're using a Windows machine or a Mac or whatever, all you need is a web browser and you'll be able to run this Python code with me. Okay, thank you so much for those questions here in the room. Appreciate it. Any questions on Zoom before we dive into the code? Okay, great. Okay, one moment, please. Okay, great. Thank you so much for that. Okay, so next up, let's talk about setting up our script environment. Okay, So I mentioned that base Python comes with a certain number of modules, and then there's other third-party libraries that you can import in, okay? So let's go through this list here, this import libraries list. So the first one, import OS, and then this last one, import sys, these are both built-in modules within Python. So we don't have to install anything extra to be able to import these into our Python script. We do, however, need to say import space OS to be able to use these modules. But other than that, that's the only thing we need to do. They automatically come with Python. These middle two, Pandas and NumPy, we talked before about how these are third-party libraries. So these did need to be or if you were doing this on your own Python instance, you would need to install those separately. However, within the Google Colab environment, these are already installed by default. So again, in the Colab environment, it's really nice because they have a lot of these very popular packages already installed. So you don't have to do any extra work to actually use them in your scripts, with the exception of doing these import statements to bring them into your script. So just to note the syntax here, import OS is kind of the standard way. So you say import space and then whatever the name of the library or module is. Now for pandas, what I've done is I've said import pandas as PD. And so that means in my script, anytime I want to reference the pandas library, I can just say PD and the script automatically knows that I mean pandas. Same thing with NumPy here. I'm going to say NP is my abbreviation for NumPy. So these are collectively called import statements. And so to run this code then, all we need to do is just click on this little kind of play button here. And that's going to go ahead and run the code. And then ideally what we want to see is a green check mark next to the code snippet. So when I hit run, it just ran everything in this one little code box right there. Okay, it's not going to go ahead and run the other stuff. It's just going to run this section right here. And this is, again, what makes these notebooks really great for instruction because we can run the code piece by piece. Sometimes I get the question in these workshops, how do I know what version of Python that I'm using? Well, using the sys library here, we can say print sys.version. And so if you recall, version is a property of the sys module. And so that's why we use sys dot and then just the name of the property. And that's going to print out the version of Python I'm using. So this Google Colab notebook is using Python version 3.10.12. And we can see that that particular version was released this past summer. So it is a pretty new version of Python. It might be the newest version available. All right, so that's how we can get some information about our Python instance. And then finally, the last step of setting up our environment is going to be to set up some local file names as variables, okay? So if we reference back to the files that we uploaded here, we can see that our first CSV, sample survey data.csv, we're saving that as the file name or as the variable name data file name 1, okay? Then we have another variable called data file name 2, which I could go ahead and call just the name of the file here. But for data file name 2, we're actually going to be using that as our example of pulling in a file that's saved publicly from Google Drive. And so instead of using the file name here, what I've done is I've pulled the sharing link from this file right here. And that's how we're going to open that file because we're just going to practice a couple of different ways of opening up the files. And then finally, we have data file name 3, and this is the first section of the file names of our large group of files here, this NAICS underscore 4451 files. So we're going to be using that to locate those files. So our little file name here. So I'm going to run that, and that's going to essentially import our variables. Just to double check, I could open up our variables list, and now I can see that the 3 variables that I set up here are now appearing as variables in my variable list. Now, if you're already familiar with Python syntax, you probably know that whenever we have this little hashtag in front of a line of code, that's a comment. So that means that Python will not be reading that line. That's essentially a way for us developers to communicate with ourselves. Oh, okay, here's what this particular code means. And it's just a way to kind of say, okay, Python, don't read that line, just only read the lines that I want you to.
So the green, that's all the comments.
Yes, yes. So just to repeat, yes, the green text, those are the comments, because as soon as we, as soon as we stick a hashtag in front of that, see how it turns green? So yes, that is us signifying that that line is a comment and it will not be read by Python. Python's going to skip right over it. Okay, so we ran that. Now we're finally going to start working with our data here, okay? So the first thing we're going to do is we're going to use that read CSV function to read in the very first CSV file. So we're going to say, okay, pd.readCSV, that's the name of the function. And then this function is going to take one parameter, which is the name of the file we want to read in. Now, after we read in that file, it's going to be saved as a variable called data. All right. And so we're going to be working with this as a variable called data. And so anytime we need to call that data frame, we're going to use the word data to call it. So I'm going to run that. And so it ran without issue. And so now let's just go through a few examples of how we can get some more information about this data frame. So the first thing we're going to do is we're going to output the shape of the data frame. So again, this is going to be a tuple that's going to have the number of rows as the first value and a number of columns as the second value. And the shape is a property of our data frame. So we just say data.shape. Okay, and that tells us that this particular data frame has 1,068 rows and 5 columns. If we want to actually see what those 5 columns are, we can use data.head, and this is a method associated with the data frame class. So that's why we have parentheses, all right? But we do not need to insert any parameters. We can just say open close parens, and this is going to give us by default the first 5 rows of the data frame. All right, so once we run that, it prints out below the first 5 rows of the data frame, and we can see that that's the exact same as if you don't need to do this. I'm just going to pop this open again. We can see that this reflects what is being shown here in our CSV. So it's just a way to preview that data. Next up, we're going to look at count, the count method. And so this gives us the number of non-null rows for each column. So let's see what that looks like. Okay, so remember up in this shape, we know that we have 1,068 records in this data frame. So what this is telling us is in the case column, we have 168 records that are not null. And same with city, state, and zip. But then when we get to the income column actually does have some null values in it. So it's telling us that we actually have 1,063 records that are non-null in that particular column. If we use describe, so by default, describe is going to give us some information about the numeric data types in our table or our data frame. So Python is going to go through and it's going to try to interpret what it thinks are the data types of the incoming data. And so it looked at case number and it was like, oh, these are all numbers. So case number must be numeric. Same thing with zip code. Well, that's not exactly true, and we're going to be dealing with that here in a little bit. But for now, it's saying, okay, we've got 1,068 non-null records. The mean of those is these. The standard deviation is this. Here's the minimum. minimum, and then the quartiles, and then here's the maximum. So by default, the describe method only gives us numeric types. If we want it to go ahead and include all the columns, we can insert a parameter into the describe method, the include parameter. So we can say include equals all as a parameter within our data.describe, and this is going to show us the same thing, but it's going to give us that for all the columns. All right. So here's case number and zip, which it already gave us, but city, state, and income it added in. Python is not recognizing at least income as a numeric value right now. So of course, it's not going to be able to give us a mean, a standard deviation, a min and max, and so on and so forth. But this is just a way that you can kind of, really interrogate your data and see what you're dealing with before you start to, kind of work with it. And then also we could say, okay, I want you to only show us certain kinds of data types. So if we say include and then pass in a list, so this is a list that has just one value in it, the object. So this says, show me any column where the data type equals object. An object is actually kind of like a mixed data type. So if Python isn't really sure what data type a column is, it will just say it's an object. And that means it probably has text and numeric values in it. Or it's just saying, I'm not sure, I'm just going to call in an object. And so most of these are going to come in as objects. So if I run this, we can see that the 3 remaining columns, it went ahead and it gave us information about those. Now, what it does tell us here is it's saying that the city column has 7 unique values in it. So it goes through all the values and finds out which ones are unique. The highest value that we see is city equals St. Louis, and we're seeing that 367 times. So this is just, again, just another way of kind of getting some information about your data without really having to work too hard. All right, what questions do you have about interrogating your data with these data types? Okay. All right, so now we're going to jump into kind of like our imaginary steps that we need to take for our data. Okay, so let's say I'm working on a project, and for my project, I need a few different things. I need all the zip codes to be strings. I don't want the zip codes to be numbers. I need all my income values to be numbers, numeric, so I could maybe do some analysis on them. I need to make sure that in my city name column, all of my city names are valid and I'm using consistent naming across all my names. So we'll see here in a second that we're going to have a lot of different ways of saying the city name St. Louis. So we want to make sure that we have a consistent way to refer to the city of St. Louis. And then finally, we need to make sure we've got a second data table here, and we need to make sure that we can take this first table and join it to our second table using zip code as a join field to match records. So let's see how we can start accomplishing these goals. The first thing we're going to do is take a look at the data types. So let's see what the data types that Python initially applied to our data frame. So to do this, we're going to access the dtypes property of the data frame by saying data.dtypes. Okay, so this is saying, okay, case number, I think that's an integer. City, state, I think those are objects, which is a mixed data type. Zip, I think that's an integer. And income, I think that is an object data type. So essentially it got every single one of these wrong. So we need to do some work to correct the initial guesses that Python made. So the first thing we're going to do is our zip codes. So all the values in zip codes are being interpreted as integers. We actually want our zip codes to be interpreted by strings because zip codes are actually categorical variables. They're not numeric. we might as well be saying zip code ABCD, they just happen to be given numeric names. So what we're going to do is we're going to say, okay, within the data frame here, we're going to look at the column name zip, and we're going to apply all the records in column name zip. We're going to change them to be this section, this bit of code here. So the new values are going to take data.zip, or the values from our zip code column, and it's going to be essentially changing them to strings using this as type method here. So we're going to say, okay, take all the records for zip and convert them to the type string. So now all of our zip codes are going to be strings. So let's run that little cell. Okay, that ran fine. Now let's check our data types again using the dtypes property. Okay, awesome. So now when we look in our zip column here, now it's telling us that zip code is a string, and that's great. We have accomplished our first goal. Woohoo! All right, so now let's move on to the income column, because we want our income column, we want all of those values to come in as numeric. So they're being interpreted as a mixed type, but for our analysis, say we're going to take a look at the average income for our participants or something like that. We need those to be numeric values here. So what we're going to do is first, I just want to look at all the values that are coming in as numeric, or excuse me, as income. So what we're going to do is we're going to do a little loop here. Okay. So the syntax for loops, this is going to be a for loop that's going to iterate through whatever we tell it to iterate over. So the syntax is for some variable in whatever you're wanting to loop through. So let's start with this syntax here. So what we want to do is we're saying, okay, take the data frame, and within the data frame, look at the income column, and then find all the unique values within the income column. So we have 1,000 plus records in our data frame. Go through those 1,000 plus records and find all of the unique values in income. Okay, so that's going to be essentially our list. Then when we incorporate the loop here, it's going to loop through each one of those records. And as we loop through each one, the record that we're currently on is going to hold the value of V. So then when we say, okay, print V, it's going to print that particular value. So when we run this loop here, we can see that it's gone through that whole list of unique values, which there's going to be probably close to 1,000, because a lot of them are going to be unique themselves. And it's given us this whole entire list of values. Okay, thank you for that. This is a really long list here, and I could scroll and scroll and scroll and scroll and scroll. But this was just to kind of introduce that first introduction to our for loops. I don't want to have all of this kind of clouding up my notebook. So I'm going to right click and say clear output. And that's going to essentially like remove all that output just to keep our notebook nice and clean. But we looked at all those values, and oh, you know what? Let me just do that one more time, because what I wanted to show is we actually have a value of St. Louis coming through in our income column. And so that is actually probably a typo of some kind, or someone maybe input their city in the wrong text field or something like that, which totally happens. Data is dirty. So this was just a way to see, oh yeah, I've got some weirdness in my income column. All right, I'm going to clear that out. Yes.
Sorry, I don't have any Python background, so this might be a little.
No, it's okay.
I know you say like V as like value, and this is kind of like search from all the data, like you are searching for the income value, but what are those numbers in common, like why they are together, like when you are searching that, what does that mean?
Okay, yes. So the question was about searching values, and I just want to correct that a little bit. We're not necessarily searching for values here in this loop. What we're doing is in this section of the code here, we are, I guess you're right. We are searching a little bit, but it's kind of happening behind the scenes. What Python is doing is it's looking in the income column and it's finding all of the unique values within that column. So say we have like, two people said that their income was $10,000 and three people said that their income was $15,000. Well, those values would show up as $10,000 would be one unique value and 15,000 would be another unique value. So that list that we're pulling is not the income for all the records. It went through and it said, okay, of all the records, here are the unique values for income that people input. And so this is what the purpose of this was, just to look and see, okay, something is making Python think that this income column is mixed, like it has both text and numbers in it. And so the whole point of looking at the unique values was to figure out, well, what is that value that Python thinks is making it a mixed data type and not just a straight up numeric data type. And so when we did this and we printed out all those values, it's a very, very long list, but we can see that one of those values is St. Louis that came through in our income column. And that's obviously not a valid income value. So this was just to kind of give us a little hint as to what might be wrong with this data. What might we need to fix about it? Okay, so I'm going to clear my output there. Okay. All right. So our exploration just now told us that we have the value of St. Louis in our income value or in our income list, and that is invalid. Now in there, we also have a value of none, which is fine. We can have a null value, but we want to make sure that it's recognized as a null value and not like the word none or something like that. So let's go back and let's use the same action that we did here, trying to convert using the as type method. Only this time, let's say, okay, take our income column. So in our data frame, we're going to look at the column called income, and we're going to change that to the value of income as type integer 64. So essentially, I want you to take those values and I want you to convert them all to integers. So let's see what happens. I'm going to run this. Okay, so I got an error. So let's take a look and see what we did here. So obviously it tells us error straight away. It underlines it in red. It gives us a red little circle here. So if you weren't sure, it's an error. And so what it does here is this message. It says, okay, here's the line of code that spit out that error. So it's the only line of code here in this little snippet. It's this one here. And then it tells us a little bit about what the error is, but usually you can look down here at the bottom and it kind of gives you a summary as to what that error is. So this says it cannot convert float nan to integer. So it's saying it's finding a null value, or nan stands for not a number, and it cannot convert that to an integer. All right, so we need to come up with some other strategy to convert all these income values to integers. All right, so that didn't work. Let's try another function. So I'm going to say, okay, take all of my income values here, and I'm going to try a function within pandas called toNumeric. And so I'm going to say, okay, pandas.toNumeric, and I'm going to say, okay, what do you want to convert to numeric? I want to convert all the values in my income column. Okay, so let's run that. And I get another error. Darn it. Okay, well, let's see what's going on here. This says unable to parse string St. Louis. And it gives us that same one. It's saying in record number 1058, you've got a string called St. Louis, and I can't convert that to a numeric value. I don't know what to do. So I'm just going to give you an error and say I can't go on any further. Okay. All right. So this strategy Didn't work out so great for us. So now we go back to the drawing board. Maybe we do some Googling. Maybe we ask our chat GPT what to do, but somehow we try a different strategy. All right. Programming is all about trying different strategies. So let's try this again. I did some research and I found out that within the two numeric function, first parameter is going to be what I want to pass through. But if I introduce a new parameter called errors, then this instructs Python, what do I do when I encounter an error? Because before, when Python was encountering an error, it was just crapping out on us. It was giving us an error and it wasn't moving forward. Now I'm going to say, okay, if you come across an error, I'm going to instruct you to cohorse, which basically means that if you run across any invalid values, you're just going to change them to null. All right, so just get rid of them. Because if we have any values that aren't income, they're not going to be useful to us anyways. So I just want you to make them null. All right, so let's run this. Okay, that's good. We got our little green check mark, so we didn't get any errors. That's awesome. Now let's take a look at those unique values again. This is using the exact same code as before. We're going to look at all of the unique values of our income column, and we're going to print them out using this list. Okay, so a couple things have changed. First of all, I can see now each of my numbers has this .0, which pretty much indicates to me that they are numbers now. And then if we scroll down a little bit here, or maybe up, let me see if I can find it fairly quickly. We should be seeing a nan or a null. And this basically tells us that anything that was invalid, it went ahead and changed to null for us. Let's see if I can find that here. I'm just kind of slowly scrolling through this list. Maybe one of these days I'll get a shorter list. Yes, NAN. Did you find it in yours? Okay, great. Maybe one of these days I'll find it in mine. Here we go. All right, there we go. So essentially our instance of St. Louis and our instance of none, those all went away. They were all switched out for none or NaN, which stands for not a number, which is another way of saying null. All right, awesome.
Both items, like, see the arrow as like valid and just change that to null.
Exactly. Yeah. So the question is, did we tell Python to see the invalid value and change it to null? And yes, that's exactly what we did. Exactly. Yes, we ran the same list again. We said, okay, give me all the unique values and then print them out. And so we didn't see the word St. Louis in there anymore. That's good. And we saw the word NaN, which basically means that some values had been converted to nulls. And we'll see those records a little bit later on, because there was one particular record that was completely messed up, and that's the one that's been messing up a lot of our data cleaning steps here. Okay. What other questions do you have on either converting the data types to strings or to numeric?
I know like those numbers, they are all like numeric, but what is a string?
Yes. Question is, what is a string? So a string is text. So your two main data types you're going to have in most data sets are either going to be string or text, so words, phrases, things like that, or numbers. And so those were the two examples we went through, because those are kind of the two most common data types you're going to be working with when you're working with just tables of data. Okay. So next up, we're going to talk about how to get some consistent values. So For our analysis, we're going to be aggregating these values by the city column. And so those values are going to need to be consistent across all of our cities. So we can use our same strategy that we used up here, this data income unique. We're going to use that again. And we're referencing our city column in a little bit of a different way, but the functionality is the same. So we're going to say, okay, go into our data frame, which is called data, look at the city column and give me all of the unique values of in the city column. So I'm going to run this and we can see that this list is quite a bit shorter because we only have a handful of values that people placed in for their city. And so we have a couple of different things happening here. First of all, if we look at this list, we've got ST space Louis, we've got Saint space Louis, so Saint written out. Skipping a few, we also have ST period space Louis. So 3 different ways of referring to the city, St. Louis. If we examine a little bit further, we can see that we've got U City, and then we also have University City. So 2 different ways of referring to University City. Then Kirkwood's fine. But then in our city list, we also have at least one record that is city equals Mo or Missouri. And already I can tell that doesn't seem right to me. It's probably the state is supposed to be Mo, not the city. So we need to do a little bit of cleanup here. So let's take a look at University City first. So in our exploration of using pandas and data frames, along the way, there may be some instances where we need to create new columns of information, like I mentioned at the beginning, adding new columns on. So to add a new column, we use the same syntax as we used before here to say data, look at the income column. But when we run this, Python is going to recognize that data does not have a column called country. And so that is the signal to Python that it needs to actually create a new column called country. So we're going to say, okay, create a new column called country and just populate it with all USA. Like every single record, I want you to say USA is the value. So if we run that, and then we use our head method here to get the first 5 rows, we can see here's our first 5 rows, and then it's added this new column called country, and it's populated each record with a value of USA. Okay, so that's just a quick, here's how you create a new column, okay? So let's take this knowledge here and let's create a new column with the corrected city name. So what we're going to do is we're going to go back and we're going to use that replace function that we talked about at the very beginning. And we're going to pass in 2 parameters. We're going to pass in to replace, which is the string we're going to replace. And then we're going to use the value parameter to pass in the string that we want to replace it with. So explaining what this syntax here is going to do. We're going to, in our data frame, we're going to create a new column called city underscore corrected. And in that new column, here's what we're going to pass in. We're going to take the current value of city, and then we're going to run this replace function on it. So what this says is, if in this incoming value, if you see U City, I want you to replace that with the value University City. So it's going to go through and it's going to, the original column that's called city is going to stay the exact same. But in this new column, any instances of U City are going to be replaced with University City written out. So let's see what that looks like. I'm going to run this. Now I'm going to use my unique method again, and I'm going to find all of the unique values in my new column, city corrected. So in my data frame, in my city corrected column, give me all of the unique values. I'm going to run that. So now I still have all my 3 St. Louis's. We didn't do anything with those, but now I don't have U City anymore. I just have one value, University City. So all of my U cities were changed to University cities. That's good. If we want, we can take another look at how to kind of examine our values that were changed. We can create a new data frame called uCity. And for that, what we're going to do is we're going to say, okay, take the existing data frame. And then these square brackets here essentially are telling us how to subset a particular set of records. So we're using square brackets in several different ways throughout this workshop. And so this is another way within pandas, the square brackets indicate a subset of your data frame. So I'm going to say, okay, subset my existing data frame and give me everything where the city column is equal to uCity. And then this little pipe here signifies or. And then we have another criteria, or city equals university city. So this is saying take everything in my data frame and only pull out the records where city equals uCity or city equals university city. And then once you've done that, I want you to go ahead and just print out the first 5 records using the head method. So once I run that, it's now plotting out the first 5 records of our new uCity data frame. And I can see that some of the original city values were uCity and some of them were university city. But in my city corrected column, they've all been corrected to university city. All right, so just a couple of different ways of interrogating your data. We also noticed in our list that there was a city with the value of Mo, which is not correct. Using this same method that we just did, we can say, okay, show me all of the records where city equals Mo. So we're going to say, okay, in my data frame, and then here's my square brackets telling me that this is how I'm going to filter out. Give me all of the records where city equals double equal sign Mo. Now, just a note on these double equal signs here. Whenever we are testing for equivalency, so if something equals something else, we need to use double equal signs, because a single equal sign in Python is actually an assignment. So we're saying uCity equals this whole thing. In this instance, we're saying evaluate if the value of city is equal to Mo. And so in that case, we need to use double equal signs. So I'm going to run this, and it looks like there's one record that popped out here. It's case number 1059. The city is set as Mo. The state is also set as Mo. The income value is set as Nan. So this must be one of the ones that was replaced when we ran our income replacement function earlier. That was probably the one where it said St. Louis is our income. And so we're working towards getting this record corrected here. So some values are placed in the wrong column. St. Louis was showing up on our income column. So we're going to use the replace function again, but this time, instead of creating a brand new column, we're going to use the in place parameter to say, I want you to replace these values right within the city column. Don't give me another column. Just take what's in the city column and replace it. So we'll do that by saying, okay, in the data frame data, in the column city, run the replace function. What is the string we are looking to replace is Mo. What are we going to replace that with? We're going to replace that with a value of st period space Louis, because that's what my project team has decided we're going to use for St. Louis. And then we also include the in place parameter, and we're going to set that to true, meaning I want you to do this data swap in place. So if I run that, now we again isolate this record. In this case, we're going to use the case number here. So case 1059, we're going to say, give me all of the records in the data frame where case number equals 1059. All right, so now we can see that the city has been replaced with st space Louis. State is the same. And so now our record is becoming closer to being an accurate record. Yes.
So like from here running the replace code like, we will replace all the mall to send from Space Louis.
Correct.
How should I like make sure we are only replaced for that only case, not for the whole list?
Yes. So the question was, how can we guarantee that only the records for Mo get replaced and not the entire list?
Like not, why it's only like the 1059, that one, it's why not the whole?
Yes, yes. So why did it just occur in this one record? Okay. So in this code here, we said we're going to look in the entire data frame and we're going to find only the records where city is equal to Mo. So we did that, and it was just this one record where case number was 1059 and the city was equal to Mo. So we already knew that we were just dealing with the one record, okay? So then when we ran our replace, it kind of did the same thing. It said, let me find all the instances where city equals Mo here, and I'm going to replace them with ST Lewis. All right, so this is where we're saying only replace it if the city equals Mo, and then replace it with ST Lewis. So then once we did that replacement, we know we couldn't check that by saying city equals Mo anymore because the city was not Mo anymore. And so this was just a way to go back to this particular record 1059. Since we knew that this was record 1059, we used the same strategy, only this time to pick out all of the cases, all of the records where case number equals 1059, which is just one. And so that's how we were able to say and confirm that yes, where our city used to be Mo, here, now it is St. Louis. Yeah, no problem. Good, great question. Okay, so far that's looking good. Let's use this same strategy of in place to go ahead and correct our U city values too. Now, before we had created a new column called city corrected, and we replaced our U city values within that column. This time, since we're familiar with our in place strategy now, we're going to go ahead and just replace, do this in place. So within the city column, any instances of U city are going to be replaced with University City. All right, so I'm going to go ahead and run that. Then if we look at the unique values of city again, we're getting closer. We still have our 3 instances of St. Louis here, which we're going to tackle next, but we only have one value associated with University City, and that's University City written out. And we can also see that our value of Mo is gone. So we're not seeing that anymore. Okay, so now we can move on to correcting our St. Louis values. All right. Now we could use the same message as we did for University City, and I'm seeing a typo in my thing, so I'm just going to fix that right here. University City. There we go. But I'd like to introduce you to another way of handling kind of pattern finding, and that is regular expressions. So regular expressions is a way to find a little bit more complex patterns within our text. And this would be what, in my opinion, a great use of using your AI tools. So your Chat GPT and so on and so forth. You can say, here is what I want to try to find. Help me create a regular expression to find this. So we're going to go back to the presentation. So essentially, regular expressions are kind of like wildcards on steroids. So we can try to find lots of different instances of St. Louis. So we know that all of our instances of St. Louis are at least going to include the string Louis. Okay, so that's one way that we can look for them. But we want to find basically anything that happens before the word Louis. And if it has something and then Louis, then we can be fairly confident that it means St. Louis, and we can do our switching out. All right. So I used to struggle like writing regular expressions because it's kind of like almost a programming language in itself. But nowadays with Chat GPT and stuff, it makes it a lot easier to figure these kinds of things out. but the regular expression is going to use a number of symbols that represent different patterns. So the first symbol here, this little caret, means that all of this pattern within the parentheses has to be at the beginning of a string. So at the beginning of a string, you have something, and within the parentheses, it indicates, okay, here's what we're trying to find. We're trying to find any character, and then we're going to try to find any number of instances of the previous character. So this basically means anything before Louis, we're going to assume that that is St. Louis, and we're going to use that replacement. So we could probably spend a good 2 hours talking about regular expressions. That's a really, really quick introduction to regular expressions. But I do invite you to check out Regex 101 or W3 School's Python Regex page to get some more information about regular expressions. Regular expressions is a built-in module for Python. So we don't need to install it, but we do need to run an import statement to import it into our script. So that's what I'm doing here, is I'm just running that import statement. And then we need to find the pattern to look for. So we just talked about the pattern, and I've basically indicated this pattern. I've repeated the pattern from the slide right here in the code. So what this is doing is this saying, okay, create a variable called STL pattern, and it is going to be a class from the regex library. And here is what it's going to mean. So this basically means anything, then space Louis. So if we come across any values that are literally any other characters and then a space and a Louis, we're going to assume that that's St. Louis, and that's what we're going to replace it. That's going to be our indication that we're going to replace it with our new way of referring to St. Louis, which is ST period space Louis. All right, so I'm going to run that to get that variable in. If I'm curious, what is the data type of this variable? I can use the type method. And this tells me that this is a regex pattern, .re.pattern or re.pattern. All right, so now we're going to go back and we're going to use our replace function, only this time in the toReplace parameter, what I want Python to look for is our pattern that we just created here. And then if you find that pattern, what I want you to change it with is ST period space Louis. That's what we've decided we're going to refer to St. Louis as in our project. We're going to do that in place, yes. And then one final parameter here, we're going to say regex equals true, which means when you're running this, I want you to remember that we're using regex here. We're not using like straight up strings. Like I don't want you to literally look for the caret, the asterisk, and the question mark. I want you to realize that those are actually regex characters, and I want you to recognize them as such. So that's where the regex equals true comes into play, that parameter there. So we're going to run this. And then finally, we're going to take a look at all of the unique values in our city column again. And voila, we have taken all of our 1,000 plus records, and we found all of the instances of St. Louis City in its various different iterations. And then we've replaced them all with ST period space Louis. And then we also have our Kirkwoods and our university cities. Okay. All right. So what questions do you have about those data types, regex, anything like that?
I want to ask, what is a pattern?
Yes. So the question is, what is a pattern? So the pattern is essentially the sequence of characters or sequence of strings that we need Python to find and then replace. So in our earlier examples, the pattern that we were having it find is just something simple like find everything that's U city and then replace it. For St. Louis, we had a little bit more of a complex pattern that we wanted it to find. We wanted it to try to like find all these things at once. And so that's why we brought in the regex to find a little bit more complicated pattern and then use that same pattern, but still replace it with a single value. Okay. All right. So as time is quicking by very quickly, we're going to move on to joining tables. So, and we've already accomplished kind of our first set of goals. We changed our data types. We made all of our city names consistent. But the last goal for our project was to make it so our table could be joined to another table. Okay. So this is where we're going to practice um, bringing in a table, not from a hard file or a local file. We're actually going to bring in a table from Google Drive. So like I said before, in our folder here, we've got this table, STL city population. And if I were to share this folder, see if I copy this link, and then I go back to my Google notebook here. I'm just going to paste this link. Oh, shoot. Sorry. There we go. So this is the link. If I were to say, hey, friend over here, I want you to look at this file, this is the link that I would pass. Okay. So this is the same link that we, if I use my jump menu here, this is the same link that we're looking at right here. Okay. So I just wanted to show you where I actually got that link. Okay. So we set that whole file path, we set that to data file name 2. And if I run that, it's just going to print that out here. Okay. So what we're going to do is now we're going to do a split. So a split is another method associated with the string data type. And so what it does is it goes through the string and it looks for all of the characters that you designate as the split characters. And then it splits the string at those characters. So it looks something like this. I'm going to create a variable called URL split. And to do that, I'm going to take this data file name 2 right here. And I want you to split it anytime you see a /. I want you to split. So the output of this is going to be a list of all of the different chunks of that string split by the /. So let's take a look at that. I'm going to run that. And then in this next line, I just print that out. Okay. So here I have a list. I know it's a list because it's designated by square brackets here. The first chunk is this HTTPS. So I can see that here. See, it got split. Then we have a little space because we had just 2 slashes there. Then the next chunk is drive.google.com. There's the next one. And then it split at file. Here's there. And then it split at D. And then it split at this long kind of string of numbers and letters here. And then it split at the last part, the sharing part. So within this list, the key that we're looking for here is this long string of numbers. So what this is the unique identifier for this item in Google Drive. No other item in Google Drive anywhere in the world has this same identifier, okay? It's only for this particular file in my Google Drive. If you have your own Google Drive, you're going to have an entirely different set of item IDs, and it's going to be completely different from the person sitting next to you, and so on and so forth. There's no duplicates there, okay? So if we want to identify a particular item, we can use this ID to retrieve this file. So in order to read the file into Python or into our notebook, we don't want to use this sharing URL. We actually want to use the download URL. And so what we're going to do is we're going to use this identifier here to build the download URL for this item. Like, so if we were to say, go to our Google Drive folder, and if I say right click and download, nowhere in the user interface do I see this download URL, but behind the scenes, this is what's happening. We're actually going to a download URL, and that is allowing the file to be downloaded. All right. So the download URLs for Google Drive items look like this: https://drive google.com/UC?ID equals, and then it wants you to drop that ID in there. All right. And so what we're going to do is we're going to build a string that's that URL. So the first part is going to be this first part. And then whatever it is, we're going to take our URL split list here, and we're going to say, give me the second to last item in this list. So that's where the whole -2 comes into play. This item here is the -1 item. This item here is the -2 item. That's going from the back of the list. If we were going from the front of the list, then this item would be item number 0. This item would be item number 1. This item would be item number 2, and so on and so forth. But in this case, we know that we don't want the sharing one. We want the second to last item, and that's this ID right here. So that's why we use the -2 indicator right there. Okay. So if we build that string and then print it out, let's print that out. Okay. So now it's already recognizing it as a link. If we were to click on that link, then it would automatically start downloading that file. So that's how we can double check that this link is taking us to the correct file. It is. I can see in my downloads here that it already downloaded that file. So this can be really handy if you need to like programmatically access items from your Google Drive. All right. So we're not actually downloading the file. We're just kind of using that download link to actually read the file into Python. Okay. So remember how before when we used the read CSV function, we actually used the file name and we said read in this file name? In this case, what we're going to do is we're going to use the read CSV function, but instead of putting in the file name, we're going to put in the URL that we just created. So that is behind the scenes going to essentially download, quote unquote, download that file and read it into our Python notebook. Okay, so this line of code here is reading in the file, and then I just put the name of the data frame here so it would print out below this code chunk. So let's go ahead and run that. I also am going to close this side panel here. Okay, so it successfully read in that file, and then it's printing out the entire data frame for us, which is about 30 records or so. And it's showing us essentially everything that's in that CSV, but now it's read in as a data frame within our Python instance, and now we can work with it as a data frame, just like we were working with the previous table. All right, I'm going to right click here and I'm going to say clear output. Okay, now I want to only, since we're working on the zip code column here, because recall, we want to take this table and we want to join it to our previous table using zip code as our join field. All right, so I'm going to say, take our demographic data frame, and I want you to only show me the zip code column. All right, so I'm going to run that. And so now here's that same data frame, all 30 records, but just showing me the zip code this time, just to kind of check it out and see what's going on. I'm going to clear that output. So now I want to create a new column, and I want to convert the zip code values to strings. All right, so what I want to do is I'm going to create a new column, and I'm going to say, okay, in my demographic data frame, I want you to create a new column called zip, which incidentally is the same name as the zip column in my previous table. And in order to create this new column, I want you to take all of the values from zip code column as they are now, and I want you to convert them to strings using our as type function that we looked at before. All right, so let me run that. Now, if we take a look at the D types, the data types of our data frame demographic data, I'm going to run that. And so now I can see before my incoming zip code column was an integer, but now my new zip column that I just created was a string. And that's great because if you recall, before we converted our previous data frame zip code column to string as well. Okay, so now we can merge those two tables. All right. And we're going to merge the two tables using that zip code column. And to merge them, there is a function in Pandas called merge. And we're going to use two different parameters within that merge column. We're going to use the on parameter, which tells us the name of the columns that are going to be matching. So the zip code column in table 1 and the zip code column in table 2. And then the how parameter tells us the type of join. So this would be a good time to maybe review the different types of joins when we are joining two tables together. So I'm going to go back to the presentation here. All right, joins. All right, so say we have two tables here. So now we're doing some kind of just examples. We have table A, which is a list of authors. Each author has an identifier, first name, last name, and a category. Then we have table B, which is a table where each record is a particular book. We have the title of the book and the price of the book, and then we have an ID that indicates the author of the book. So instead of writing out the author, we have an ID that matches up back to our author's table here. Okay. The four main kinds of joins are left joins, right joins, inner join, and full outer join. So what this means is if we do a left join, all the records in table A remain, and only the records that match the join field in table B are brought over. A right join is the opposite. All the records in table B are retained, and only the values from table A that match are brought over. An inner join is where only the records from both tables that match are brought over. And a full outer join is where all the records are brought over, but you might have null values for the records that don't match. Okay, so that's a lot. Let me give you some examples using table A and table B that we just looked at. Okay, so table A is our authors, table B is our books. So for a left join, all the records from table A are going to be retained, and only the matches from table B are going to come over. So from our two tables, the first record, second record, and third record all had matches in table B that matched the ID, but this author here did not have any matching books in the book table. So the columns for this record are null because there were no matching records in table B. So this is an example of a left join. A right join is just the opposite. We're going to have all of the books in table B that stayed, and then only the values from table A that match are going to be joined. So we had all the first three records matched by ID, but then our last book, Modern Art, the author of this book, their ID was not included in the table. And so this author, this ID did not have a record in our table A, so no values came across for that. So that's a right join. An inner join is where only the records that match result. So only the three records that matched by ID and this ID appeared in both tables. Those are the only records that exist in our output table. That's the inner join. And then a full outer join is where we have all of the records from both tables, but they might have null values in the records that didn't match. So again, we have all three of our completely matching records are at the top. Then from table A, this author, Emily Stevens, has nulls for the book title because Emily Stevens did not have a record in the book title. But then we have the book Modern Art, which did not have a corresponding record in the author table. So that's why there's null values here. So that is the full outer join. Okay, so going back to our Python notebook, on how what we're going to be doing is a left join. So we want to keep all of the records from table A, which is going to be our survey respondents, and we're only going to keep the matching records from table B, which is our demographic data that match by zip code. So let's take a look at the code for merging here. So we're going to create a new variable called data with demographic. And to create that new variable, we are going to go to pandas and run the merge function. The first two parameters are the two tables that we want to merge. We have table A, which is data. We have table B, which is demographic data. Then the next two parameters are giving instructions on how we want to do this merge. The first one is, what is the name of the column that has the matching values that we're going to merge on? And that is zip code. So in my example in the presentation, the merge field that we were going to merge on was the author ID. In this example, we're going to be merging on the zip code. And then finally, how do we want to merge them? Well, we're going to do a left join, which means all of the records from the survey data will be retained, and only the records from demographic data that match by zip code are going to come over. So we're going to run that merge, and then I'm just printing out the data frame here so we can see what that looks like. Okay. So the data frame was quite large. So in the interest of screen real estate here, it's giving us the first 5 records and the last 5 records of the table. So we can see here in the 1, 2, 3, 4, 5, 6, 7, the first 7 columns are columns from our survey data table. And then the last 1, 2, 3, 4, 5 columns are the columns from our demographic table, or table B. And we can see that in some of the records, the values matched. So here we had a record with zip code 63108, and that matched with the record 63108 from our second table. Same thing with 63130 and 63110, they matched. But then in our table B, we did not have any records that matched 63122. So here's 63122, 63122. See how these values are null here? That means that no records in table B matched those zip codes. So that's why we're getting nulls. And we can also see that for these zip codes, which this is all the same zip code here, we're getting all nulls here. Okay. All right. So that is just an easy way of, when you're bringing two tables together in Python, or excuse me, pandas, you can get to know those different join types, and you can join two tables really easily together to work with them as one giant data frame instead of lots of different tables floating around. Okay. So far, we know that we match some values, but let's see if we can match the values that match, or if we can isolate the values that match, so we can actually see how good our join went. These records that have NaN in them are not going to be helpful, say, for the next phase of the project. So we're going to go ahead and isolate those out, or get rid of those. So what we're going to do here is we're going to isolate the records where zip code from the second table is not null. So if zip code from the second table is not null, then that means that that record has a match in table A. So the syntax looks like this. We're going to create a new data frame called join matches. And to do that, we're going to say, okay, take our data with demographic data frame that we just created up here. And I want you to isolate, giving our square brackets here. This tells us how we want to isolate the records. We're going to say, okay, take our data with demographic where the zip code value is not NA, or not null. So not NA is kind of like a built-in identifier that says this record is null, yes, or this record is null, no. So we're saying anything that's not NA, that's going to be one of our join matches. So apply that to our new join matches data frame. And then once you've isolated all those records, go ahead and print out join matches, that new data frame. Okay, so now if we look through this, we can see that we've got about 50 records here in our data frame. And now it's each one of these that actually matched. Now we do have some duplicates here. So we can see that like zip code 6308 appears here and it appears here. And sure enough, the same values were applied. So if you were doing some kind of summaries or whatever, you would want to make sure that you're not, duplicating any values. But for our particular exercise, whatever it was we were doing, we had a successful join where about 50 records matched to our zip codes. And there's all the values. Okay. Now, finally, say I want to take this information, this brand new table that I just created, and I want to export it so I can use it in some other application. Say I'm an expert in using Stata, and so now I want to do some statistical analysis using Stata, but first I need to export a CSV. So to do that, I need to say, okay, first of all, what do I want to call my output file? So I'm just going to call this survey join to demographic data.csv. And I'm going to say, okay, take my join matches data frame that I just created here, join matches. Let me just clear output there. Take join matches. And then before we were using pandas.read CSV, now we're going to use a method associated with the data frame. The method is the toCSV method. We're going to call that and say, okay, take our join matches data frame, output it to a CSV. And what do I want you to call it? I want you to call it the name of my output file variable here. All right. So I'm going to run that. It's going to export. Nothing's going to happen. But if I look like in our code, but now when I look at my file list, I've got a new file here called survey join to demographic data. Yay. All right. So that's great. I have a new file. If I double click on that file, it's going to open up a little preview of it here on the right-hand side of my screen so I can kind of see what it looks like. So far that looks good. I am noticing one thing here in my file. I've noticed that it went ahead and it exported the index of my row as part of the CSV. And I actually don't want that because all of my unique identifiers are here in the case number. So I don't want the index to just be like clouding up my CSV. So let's look and see how we can fix that. I just clicked on the more options and I'm just going to close this tab for now. All right. So if I don't want to include that index column, I can use join matches to CSV again. The first parameter is going to be my output file name, but then I can set the index parameter to false, and that means it's going to export these records without having that index value. So let me go ahead and run that. And I'm going to open up that file again. And now I can see that the index column is gone from my CSV, which is great. But on previewing my CSV, I can see another thing is I still have this city corrected column. And I don't really need that. That was kind of just like a working column for us. And so the final thing we're going to do here before we wrap up is we're going to isolate the columns that we're going to export to our CSV. So the first thing I'm going to do is if I want to just look at all the columns in my data frame, I can call the columns property of my data frame. So I'm going to say, okay, take all the columns from my data frame and put them into a list called call list. And then I'm going to print that list. Then from my call list, what I'm going to do is I'm going to say, take the items in my call list and I'm going to remove city corrected because that's the column I don't need. And then I'm going to print call list again. All right, so let's see what that does. So here's the first print statement. It printed out all of my columns from my list. Then I went ahead and I removed the column called city corrected and I printed out the list again. And now I can see that city corrected is gone. So here it is in the first list, but now it's gone in the second one. So now call list does not include the name city corrected. So now if I add a third parameter to my output statement, I say, okay, take my join matches CSV, or excuse me, data frame. I want you to export it to CSV, export it to a file with the name of my output file that I set as a variable. Do not include the index. And in this case, the only columns that I want you to include are the columns from my call list. So if I run that, that ran successfully. And then if I open this up, double click. All right. Now, if I scroll over, I can see that my city corrected column is gone. And now I have a nice, clean, fresh table that I could export and bring into a different application. So since we are working in the data in the Google Colab environment, right now this table is only saved here within our environment. If I want to export that and take that with me to another computer, I need to go ahead and right click and say download and download that to my computer. So then I have that file available for some other application to read, because applications will not be able to read it when it's still here in my computing environment. All right. Okay, so that was a lot we just went through. What questions do we have about joins or exporting? And if you're still absorbing, that's fine too. It was kind of a lot. Okay. So, since our time is kind of coming to a close, I just want to direct you to some bonus content that I included here in the workshop. All right. So, we didn't quite get to this, but moving forward down the notebook is instructions on how you can read multiple files into the same data frame, how you can add leading zeros to a column because that can be particularly helpful, some additional practice on splitting, working with dates, and then finally on reshaping tables, making tall tables wide and wide tables tall. All right. But all of this is here in this Google Colab notebook that you can take with you. I'm not going to be taking this down. It'll be available forever pretty much. So feel free to go through that at your leisure. And please do reach out to me if you have any questions. You should have my email address from the email that I sent to all of the registrants today. But just in case, if you go up to the very top, my email address is right here, just mollyweb@woostel.edu. If you have any questions about Panda, data cleaning, or geographic information systems, I'd be more than happy to chat with you about that. So all you need to do is reach out, okay? Else, I really appreciate your time joining me this afternoon. I hope you'll take a look at the library events page because we have a lot of really interesting data lab workshops coming up this semester. Like I said, this is the first one of the semester, so I really appreciate you joining me. Feel free to reach out if you have any questions, but for now, I'm going to go ahead and stop my recording and just thank you again for coming.